because there's no real volumetric volume to the sphere, you can see that in this case animated shape and lock on emitter aren't actually having any effect. So you need to be aware of this with when you distribute your particles within the volume of a mesh. You can't actually lock to it because you can't actually lock to the volume. You can only lock to the surface, the vertices, the edges, whatever it is of a mesh. You then have selected vertices, selected edges, and selected faces. And these all need a sub-object selection on your mesh. So if I use it at the moment, you can see that it's applying itself to all of the vertices. It's applying itself to all of the edges. It's applying itself to all of the faces. So if we select our mesh and we apply an edit mesh modifier, let's say, then I can actually go into sub-object mode, and I'll make a number of selections here so we can see each one in action. I'll select a face, and you can see because I have selected faces active, now the particles are just being positioned just on that face. I'll select some edges. There we go. And I'll also just select one or two vertices. There we go. So now, if I say selected vertices, you can see it's just positioning the objects on the vertices that we've chosen. I can choose edges, and it's just positioned on the edges. And as we just saw, the same with faces as well. And you can see it's locking to the face. So that's pretty cool. Now, something else that we can do is we can actually control the density of the positioning based on a grayscale bitmap that's actually applied to our object. So let's go on to our object here, and I'm just going to get rid of this modifier, and I'm going to increase the amount of steps that we have in our sphere. I'm just going to turn off our particle flow here for a second just to give us a little bit more speed, and I'm going to open up the material editor, apply this particular material to the actual mesh, and then I'm going to go into the diffuse color of our texture, and I'm going to choose a gradient. And in this case, actually no, I won't choose a gradient. I want a little bit more control here, so in this case I'm going to choose a gradient ramp. This will allow us to actually make the differences in the parts of the ramp a little bit more definite. So we'll get rid of our old map. There we go. And in this case I'm going to change this to black here. I'm going to change this to white. And this to black. And this to black. There we go. And just move this up here. We'll move this here. Change that to white. And then I'm just going to rotate this gradient ramp through 90 degrees. So now we have a little band of white, which you can see here. And this is applied to our mesh. If I turn on shaded in the viewport, you can see there we have our little band right in the middle there. So I'll just adjust this to make it a little bit slimmer. There we go. It's pretty cool. And I'll turn on our flow again, and I don't want to use selected faces because the selected faces information is actually gone now. So I'm just going to say let's emit particles over the surface. There we go. And I want to control the density by material, so I'm just going to turn that on, and it's already on grayscale. Now the grayscale option, as you can see, uses the bitmap that we've just created, sorry, the procedural map that we've just created, and it just limits the distribution of your particles to these areas. The other option we have is to use the opacity. This is useful for when you've opacity mapped your object and you want to obviously limit your particles to areas of your object which aren't actually transparent. So in this case it will actually look at the opacity map of your texture and use that as the basis for your particle placement. Grayscale and opacity will actually combine these two options, and in this particular case the grayscale will grossly determine where particles are, and then the opacity will override that. So if your grayscale determines that some particles are here but your opacity map says that this area is transparent, then you won't actually get any particles there. So you can actually combine the two and get a little bit more control with those options. The other option you can use is to use either the red, the green or the blue channel of an RGB texture. And in this way you can have different controls based on the different channels of a particular bitmap, or a procedural texture for that matter. So you have quite a bit of control in deciding how the distribution of your objects is going to take place. You also can choose to use a submaterial. So if you have a multi-sub object material applied to your sphere, then you can choose to use, say, submaterial number 3, and that could actually be used to actually have the texture, for instance, the bitmap, which determines where your particles are going to be distributed on your object. So in that case, you've got the option of having, you know, your full texture on material ID 1, and then you can have, as I said, a distribution texture on material ID 2, 3, 4, whatever it is that you choose. So you can see it's a very useful feature, and you can completely control exactly where your particles are going to be distributed on your mesh. Actually, something I'm going to skip back to is surface offset, which we actually overshot there for a second. I'm just going to turn off density by material, as that slows things down a little bit. Go back into the material, and we'll just turn off the viewport display. And we'll go back to wireframe mode. No, actually, let's stay in wireframe mode. It makes it easy to see what we're going to do next. Now, surface offset is useful for when you actually want to have your particles not appear directly on the surface. So let's just turn that on here. We'll set these values to 0 and 0. The minimum value is actually heading inwards into the surface of the mesh. So if we change the minimum value, I'll just decrease it here. Go down, down, down. You can see the particles are sinking into the surface of our mesh. So in this way you can actually have your particles appear below the surface of your mesh. And I'll use a very low max value as well, and you can see now that our particles are well within inside the shell. So I'll change that to -2, and I'll change the min to -2 as well. And you can see, there we go, the particles are just below the surface of the mesh, as I said. Of course, you can go the other way, and you can actually offset them off the surface as well. So if we change this to 0, and we change this to 10, our particles can now be anywhere from 0 to 10 units away from the surface. And if we change the random seed, you can see we get a random shuffling of the actual distribution. If we wanted all our particles to be 5 units away, I could change the min and the max to 5 units. And now all the particles are 5 units away from our surface. You can see if I scrub, they're still locked to the surface, so it doesn't actually change that feature in any way. So this is useful sometimes when you have particles which are actually quite large and you don't want them to actually penetrate the surface. So you can choose to have the particles offset off the surface. And as I said, if you want the particles to start below the surface for whatever reason, let's say it's meant to be hair, you could then use the min and max values to actually determine how far below the surface the particles are. And you could also animate them probably, so they actually change their position, so they animate into position. So you can see that's actually quite useful. As with the position icon operator, you can see that if we go down here, we'll skip on a little bit. We have distinct points only, which is exactly the same. You can choose to have 10 points, 5 points, 15 points, wherever it is that you want to do. And again, this is very useful for limiting the actual areas within which your particles can be distributed to. And another option that you have, which is also quite useful when used in conjunction with distinct points only, is to use separation. So what this will do now is it will actually, if we change this to something like 30, let's say, it will only actually distribute the particles if they are outside the distance specified here. So if I change that to 2, you can see that particle over there immediately jumped. If we change it to 3, nothing really happens. Let's try 6. and you can see a lot of particles jumped around there. What's happening now is each particle is looking for a particle which is within 6 units of itself, and